Hey everybody, welcome back to the Print 3D channel. Today is November 13th, and that means day 317 of the 3DP 365 project. And on today's episode, as you guys may well know, 3D printing isn't an exact science. Sometimes you get really great prints, like this tiny little Tika Alpaca, and sometimes you get spectacular fails. And we're going to talk about both, so stick around. Hey everybody, welcome back, and thank you for joining me here for day 317 of the 3DP 365 project. As you guys may well know, 3D printing really isn't an exact science. Every single machine prints differently, and there's so many variables when it comes to filament, you really don't know if it's going to fail or not. Most times you get really good prints as long as your settings are dialed in and your printer is really dialed in as well. It's the filament sometimes that can be the variable. Now, that's not always the case. Now, recently, I just started using MatterHacker's Standard Series filament, and I didn't do proper testing, which is my bad. I didn't go through and do a really good proper temperature test on this, like I said I was going to do in some of the previous episodes. I just jumped in with both feet and started printing, because the prints were coming out good. I was slowly dialing up the temperature from 200, and now we're at 207. And we printed out this alpaca at 207, and this is a really good model. It's a really great test model too, because it's got movable legs, and it's got some overhangs and issues in it. Now, full disclosure, it prints like this, and I saw that those overhangs where the legs are joining in with the body were going to be a bit of an air print in a turning motion. And in my opinion, that requires support material. So I put the tiniest little pieces of support material between the legs and the body, and they fell away clean as soon as I turned the legs. So it was perfect. Now I know this is a good calibration object, but it also calibrated my support material because as you can see, this is a tiny, tiny little model, and the support pieces were no bigger than that. So when they were inside there, they did a good job of sticking to the plastic, and my gMax, even with its 0.5 millimeter nozzle, laid down a good piece of support that it would actually stick and support the pieces. Because as you can see, there's no drooping there on the body parts where the legs meet. And also, I did have to change a setting for this model in Simplify 3D to get the tail to stick. Now, when I just sliced it normally, the tail was printing separately and it wasn't joining the body. So I healed this and I combined all outlines to a single model. It didn't ruin the little hinge aspect for this, so I was okay with that. But it did finally join the tail to the body, so that was a little problem. The rest of the print actually turned out really, really good. We did use MatterHacker's Standard Series filament in the gray color, and that was a perfect print. And it was even really, really good printing around those ears, and I was really concerned that those would be really under extruded or have some problems. But there were really no problems with this print whatsoever, and I didn't see any issues with delamination, which was what the next issue we're going to talk about. This print actually turned out really, really good, and it's the Tika Alpaca, and I'll put the link down in the description so you guys can download and print this yourself. And we printed ours at 100% with a 0.2 millimeter layer height, with 4 top layers, 3 bottom layers, and 3 perimeters, and only 10% infill on this tiny little model, just because I wanted to make sure it was nice and strong. We also printed this out at 35 millimeters per second because I was a little concerned with the ears, and I also ramped down my cooling to only 75% maximum speed in a step level up from 0 to 20 to 40 to 75 over a consistency of about 8 layers just to get to the cooling to the right temperature, so I didn't overcool my model and cause delamination or premature cooling issues. And those all helped because this is a perfect print. All the little legs move. As you can see, it's a super, super clean print. There were no problems whatsoever. So this turned out good. And my idea was that I was going to print a test of this for today's print, because this only takes about an hour and a half to print. And then I was going to scale it up a little bit bigger and do a nice 8-hour print so you guys could see a big one. So I was really happy with this. But then I was browsing around on Thingiverse and I came across what's called Vasemania, and it's a very good collection of low polygon vases from one of my favorite artists, and I'll put that information, that link down in the description too. And it's a huge collection of really great low poly vases, and I couldn't resist. I had to try and print one. So I'm going to put this aside and I'm going to show you guys the failure that I had. So this was the failure. It was going to be an 8-hour print, and it was going to be 400 millimeters tall, and there's another piece somewhere around here. I don't know where it is. But when I walked into the print this morning, the bottom part had started to collapse which caused a whole bunch of problems. Now I don't know if you guys can see this or not. Let me see if I can find it. Here it is. Right there, right where my finger is, some of the perimeters started to go off the perimeter area, or off the reservation as I like to say. And that caused the first failure right there. The other failure is it's just, sorry headphone users, it's just delaminating like crazy. So when I pulled it off the print bed, it just started to come off in pieces. Now it's strong up to a certain point, but that's not as strong as all the other vases I've ever printed. So to me, that was a giant failure. So when I pulled up the bottom layer to examine that to see if there was some major delamination going on, and there is. I mean, these layers are just peeling apart like this. So the temperature still isn't quite hot enough. Now the range for this filament is 190 to 220, and we're at 207. So I've got a little bit more work to do to try and get the temperatures dialed in so I can get a successful vase print. And the reason why I wanted to do a vase print in this particular purple is it's slightly translucent. As you can see, this would have been really good to have with the light shining through it to make a really cool lamp, and it's 400 millimeters tall, which makes it a really good gMax print. So I'm really going to have to dial in my temperatures here. I'm really going to have to do some more work. I really need to do a temperature tower test, and I also need to print out some small vase models so I can check the perimeters to make sure they're solid. We also printed this at a 0.24 millimeter layer height because I wanted some really thick, fat layers, and we only ran this out at 45 millimeters per second. So I figured I was going slow enough that none of the perimeters would fall off the reservation. But I think with the cooling issue, or with the heating issue of the particular filament, it's just not bonding properly. I mean, it just falls apart, and I've never had that happen. I've never had a vase be that brittle like this before. So definitely going to be dialing in my temperatures. But for now, we do have this really cool Tika Alpaca model, which was a really good test model to see if my gMax was dialed in, and it did a spectacular job on the print. And I'm probably going to print a whole bunch more of these, and this will probably be added to my standard set of test models when I start testing out filament too, because it's a really cool model. Well, that about wraps it up for day 317 of the 3DP 365 project. I hope you guys found this episode interesting and informative, and if you're looking for ways to support the channel, check out the affiliate links down in the description. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll see you guys tomorrow.